All right. So here's two sets of related words that have different meanings. You need to be able to identify which one is which. Okay, the first is internally and externally tangent. Okay, so when you're dealing with circles, two circles can be internally tangent if all the points inside of one circle are contained completely within a second circle. So if I take this blue circle and then I put a red circle, so that all of their points, all the points of the red circle, are in the interior of the blue. Again, they do have to be tangent, which means they share a common point. So here's your point of tangency. And this is an example of internally tangent circles. Right? If you're looking for externally tangent circles, then you want, or you're asking to take a look at two circles that are still tangent, but this time all the points of one circle, or of the smaller, or the circle, are completely outside or in the exterior of the other circle. Okay, so here these two circles share the single point, but the interior of one is not within the interior of the other. In this set of internally tangent circles, again, they still only share one common point. That's why they're called tangent. But the interior points of one circle are completely contained within the interior of the other circle. Okay, questions on those two distinctions? Hey, now there's another set of relationships that's confusingly similar to this. Common internal tangent and common external tangent. Again, the naming is almost the same. You want to be very careful with these. Okay, as far as what you need to do for this chapter right now, it's just to know what these mean. We're going to work with these more when we get to the chapter on triangles. Okay, but if you have two circles and there's a line that passes that's tangent to both the circles, that's where the common tangent phrase comes from. And so if you have this tangent segment or line, and it's tangent to two separate circles, it's called a common internal tangent if it passes through or crosses an imaginary line connecting the centers of these circles. Okay, so if you think of the imaginary line connecting the centers of the circle, and your tangent passes or crosses through that line, then it's called a common internal tangent. Okay, this tangent passes internally or between or through this dashed line. A common external tangent, on the other hand, exists when you have an imaginary line, again, connecting the centers of these circles. So notice now this blue line does not pass through this imaginary line connecting the centers. Therefore, this is referred to as a common external tangent. Okay. Okay, now when we get to the chapter on triangles, what we're going to do with these is the following. If we connect this center of each of these circles to the points of tangency, what kind of angles are formed at the tangent? These are right angles. And so what you wind up having is these two right triangles that are created. We're going to work with problems involving those. And then in this other figure, again, when we do the same thing, when we connect the radii, what you wind up doing is, again, forming two right angles. This time, if you box this off into a rectangle, you create a rectangle and then a right triangle on top of it. And so when we get to the chapter on right triangles, you're going to see both the common internal and common external tangent problems show up. I just want to make sure that you know what they are when it refers to those.